Hello everybody, this is Arun Lukman and Veni Madhavan from Veltech Multitech Engineering College, ECE department. Our project is Spiral Square Nano Antenna for Solar Energy Harvesting in Terahertz region. Our guide is Mr. Ruben Thomas. In this project, we have designed and characterized the Spiral Square Nano Antenna on a silicon dioxide substrate. This antenna operates in the frequency range of 3 to 30 terahertz. In this, we have investigated the antenna characteristics like resonant frequency and enhancement factor. Then we have designed the MIM tunnel diode, which is used for converting high frequency AC signal to DC signal. This is an efficient method for producing electricity from abundant available solar energy. The main objective of our project is to achieve high enhancement factor. This can be achieved by using low dielectric substrate. For this, we are using silicon dioxide substrate. This eliminates the unwanted reflections and scatterings from the silicon handle. Then the next objective is to minimize the radiation losses. For this, we have used a spiral square antenna instead of bow tie antenna, which was used in our base paper. Then the most important objective is the absorption of terahertz radiation. This is done by wearing the FSS layer.
Next, our project consists of two elements. One is an antenna and an MIM tunnel diode for rectification purpose. The output from the antenna produces a high frequency AC current which is used to rectify and convert into DC signal for commercial applications. So first it consists of an optical copper which is acts as a ground plane, and the silicon dioxide substrate is used with very low dielectric, and a square spiral antenna design is made on the top. So after the feed is given, the 3 to 30 terahertz region of operation of radiation is absorbed and is converted into high frequency AC signal. This MIM tunnel diode is used for high switching rectification application, so it converts the AC signal into DC. We have used two software, one is CST Microwave Studio and 4NEC2. We have got the antenna specific from the CST software. So the component size, frequency range and the material type is designed in the CST software, and from the optical module. The MIM tunnel diode is designed in the MEMS module in the CST software, and the output is analyzed. And the antenna parameters are imported in the 4NEC2 software, and various domains are analyzed.
Spiral square antenna. It's a combination of spiral antenna and log periodic dipole antenna. We can decide the radius using Archimedean spiral antenna. Then we can decide the conductor length and spacing using log periodic antenna. Design of spiral square antenna. We can see in the corner 4 log periodic antenna are used to construct the log periodic antenna, nano antenna, using the Archimedean spiral antenna, and the theory which is used is radiating ring theory. We can see the diagram after construction and conductor length and spacing.
Next, going to the design calculations. Desired frequency range is from 3 to 30 terahertz. From that, we have decided the wavelength. Then using the formulas, we have designed the width, length and diameter of the antenna. Then the antenna design geometries have been shown in this figure. This is the spiral square antenna that has been designed using CST software. After designing of the antenna, the mesh is being created by this is the mesh that has been created in the antenna. This antenna is being exported to another software called NEC2. In this software, we are going to given the after exporting, we will get the input conditions in this window. This is the design geometries that we have given. Then the source and load conditions have been given in the software. Then the required frequency range and other conditions have been given in the software, and then the output is being generated. We are selecting the frequency sweep and gain. Then we are generating a curve for that. After entering that, a command prompt generate is being generated, and the output status. This is the plot of standing wave ratio. Then the gain of the antenna is seen in this figure, and the impedance of this antenna can be seen from this figure, and also the Smith chart of this antenna is being shown in this figure, and these are the outputs used for measuring impedance, gain, and VSWR. From the main window, we can infer that the amount of voltage produced is in complex range is 707 plus microvolt, and the impedance obtained can be seen in the table, and the current obtained is around 0.89 milliamp. For a single nano antenna, we can obtain 0.89 milliamps of current. If we have an array of antenna, then automatically this can be suitable for conventional applications. The amount of radiated power is 6 microwatts. This is the MIM diode that we have designed. It consists of a metal and insulator in between, and the other metal. One metal is zinc and the other metal used is gold, and the metal oxide used in between is zinc oxide, which acts as the insulator. The thermal losses that are obtained using this diode is shown in this. The thermal losses are minimum, and it is negligible. Then we can see the low frequency losses that can be obtained. The low frequency losses are surface losses, ohmic losses, and total dielectric losses. Everything is negligible because it is in 10 to the power minus 6 watts. Then the amount of low frequency energy that is being generated is around 1.8 joules. These are the outputs of diode, and the energy magnetic field generated by the MIM diode can be seen in this figure. The electric surface loss density can be seen from this figure, and the electric field tangential can be seen from this figure, and the normal can also be seen from this. The electric field intensity normal can be seen, and the tangential electric field can be seen. The tabular column on the side shows the amount of electric field that has been generated using this diode. This is the total current density.
The applications of this antenna is vast, and one of the applications is solar charger. It can be used in mobiles as an alternative for all the solar cells, and it is used to prevent infrared radiation from entering into houses. Thus it keeps a cool environment. Just the square spiral nano antenna was designed and implemented successfully. The various output what we got in this project have been displayed. The output power of 6 microwatt is obtained.
Thank you.
Thank you.